Every time you gaze at the stars, you are looking into a time machine. The light reaching your eyes isn't showing you the universe as it is, but as it was, because light takes time to travel. The deeper we peer into space, the further back in time we see. Light is the fastest thing in the universe, racing at 300,000 kilometers per second. Yet space is so vast that even at this speed, starlight can take years, millennia, or even billions of years to reach us. The night sky isn't a snapshot, it's a scrapbook of cosmic history. Light travels fast enough to circle Earth 7 times in 1 second, yet across interstellar distances, even this speed crawls. The universe operates on a delay, we only ever see the past. The closest celestial body to us sends its light on an 8-minute journey. If it disappeared this instant, we'd keep basking in its glow, blissfully unaware, until those final photons arrived. Our rocky companions' reflected light takes just over a second to reach us. When astronauts left footprints there, their movements played on Earth screens with this tiny but measurable lag, proof of light speed limit. The gas giants in our solar system beam light that's hours old. Their current storms and auroras won't be visible from Earth for days or weeks. Every planetary observation is archaeology in real time. The closest sun-like star system sends its light on a 4-year journey. Any civilization there peering at Earth today would see our world as it was during the last Olympics, their telescopes showing them our past. That luminous point you might notice on summer evenings, its light began traveling to Earth when the first personal computers hit the market. What we see is literally yesterday's news on a cosmic scale. A well-known cluster of blue suns appears close together, but their light arrives from vastly different eras. Some photons left when knights roamed Europe, others during the Renaissance. The sky cheats perspective. Our nearest galactic neighbor spins 2.5 million light-years away. When its light began traveling, early humans were making stone tools. We see it frozen in that primordial moment. When scientists pointed a space telescope at nothing 4 days, it revealed thousands of galaxies, in a space smaller than a grain of sand held at arm's length, each a snapshot from a different cosmic epoch. Distant galaxies appear redder because space itself expands between us and them, stretching their light like taffy. The farther they are, the more extreme this effect becomes, nature's own redshift filter. The oldest detectable radiation fills the entire sky, a fading glow from when the universe was an infant. This microwave static is our baby picture of existence, stretched and cooled over billions of years. When massive celestial bodies explode, they briefly outshine their entire galaxies. Some we've witnessed actually died before human civilization began, we just received their final messages now. Our most advanced space telescope sees galaxies so distant their light has traveled over 13 billion years. It's not just observing space, it's flipping through the universe's childhood photo album. A hypothetical observer 65 million light-years away, training their telescope on Earth right now, would see dinosaurs roaming lush landscapes. The present depends entirely on where you are watching from. Eventually, the most distant visible objects will disappear from view, not because they are gone, but because expanding space will stretch their light beyond detection. The universe is slowly erasing its own history. Humanity's interstellar message in a bottle, now drifting between stars, carries sounds and images from the 1970s. Any discoverers will meet a version of Earth that no longer exists. The observable universe stretches 93 billion light-years across, but we'll never see beyond this bubble. Light from farther away hasn't had time to reach us since the beginning of everything. Some pinpricks of light in tonight's sky come from objects that died millennia ago. We are watching their final messages, like seeing a candle's afterimage long after it's been snuffed out. Near incredibly dense objects, time itself warps. An observer near one would age slower than someone on Earth, a real-world time dilation effect that bends light's path and perception. In a universe where light takes eons to cross space, human civilization occupies less than a cosmic eye blink. Yet here we are, decoding these ancient light signals like cosmic detectives. What appears as a fixed night sky is actually a patchwork quilt of different eras. Every point of light exists in its own distinct past, there's no universal. Now, the observable universe stretches 93 billion light-years across, but we'll never see beyond this bubble. Light from farther away hasn't had time to reach us since the beginning of everything. When you look up, you are not just seeing space, you are reading chapters from the universe's autobiography, each written in light years instead of ink. We are temporary witnesses to this grand light show.